Hello everyone, welcome to this second tutorial session of Probability Foundation for Electrical Engineer, whose instructor is Professor Krishna Jagannathan sir from IIT Madras, and I am Satyavikram Pratap Singh, a PMRF research scholar at Department of Energy Science Engineering, IIT Bombay. So we are going to see few of the problems related to these assignments, which will help to solve that, and also we will learn few of the concept which is actually very important for solving the assignments and all. Okay, so the process will be such that we will giving the few of the problems which will be a foundation for the assignments, giving the glimpse of the some of the concept which is being useful for solving that problems and all. So let's go one by one and see that how the problems are there and how to tackle these kind of problems. Okay, so the first problem is such that there is a set, uh, suppose this is set omega, which is having the element 1, 2, 3, 4, and there is a function which denote that how many subsets are possible for this set actually, and it is having a probability which is being defined as pa is equal to mod a by 4, and the probability space is such that it is asking that if you consider that that omega f and p, whether it is forming a probability space or not. Okay, if you are having the idea of this concept of the probability space, you can try to solve that, and after a few minutes we will solve that and see that how actually concepts are being formulated into that. Okay, take some time and read the problem and try to solve that. Try to solve this problem. It is just saying that you are having a set which contains the elements 1, 2, 3, 4, and there is a f which is defined as how many subsets are possible for this set, uh, uh, omega, and that is equal to 2 to the power omega, and the probability is defined as the pa is equal to mod of a by 4, and it is asking whether this omega f and p forms a probability space or not, and whose options are that whether it is yes or no, f is not a sigma algebra, or the probability of this omega that set is not equal to 1, and or p is not countably additive. Okay, try to solve this, take few minutes. Okay, let me give few of the concepts which will help to solve this. What is saying in this problem that you are having a set which is denoted as, that is, let me erase it. So it is saying that ki you are having a set omega which is having element as 1, 2, 3, and 4. And if you ask that ki how many subsets are possible from that, how many subsets are possible, the total number is such that that is equal to f 2 to the power omega, that is a number of element, that is here four elements are there, that is 1, 2, 3, 4. So overall sets which is possible, that it's a 16. Okay, you can write it also like that, f is equal to one set as a 5, one as a single elements like 2 or 1 or like that, or 3 or 4, or when you see that taking the two elements together, that is 1 2 dot dot dot, and you taking the three elements also possible, that 1 2 3 and all dot dot dot. So there are 16 subset which is possible from this set. Okay, so these two concepts are clear that first how many, if there is a set, how many subsets are possible from that. See from here that and also this is a sample space of that. Okay, so the sample space will be such that of omega is, there is a 1 2 3 4 elements are there, and there is a four possible outcomes from that sample space of omega. Okay, means possibility of the numbers will be such that either one will be there, two will be there, three will be there, four will be there. So there are four possible outcomes because the four elements are there in that set. Okay, and the event collection means ki how many possible subsets are possible, that we have already seen that ki it's a 5 1 2, taking one elements are common, two elements are common, three elements are common, and the four elements are common. So total it's a 2 to the power n. Here 4 is there, so it's 16 subset in the total it is possible. An important point is that when you see this probability function, that p is equal to mod of a by 4, what do you mean by that? Okay, so for example, I am taking a set which is 1 2. There are two elements are there. So mod of a means how many number of elements are there in that set particularly. So here 1 2 it means subset. So mod of a is 2. So the probability of a will be equal to mod of a, that is equal to 2, that is divided by 4 because it's a 4 is given already. So it will be 1 by 2, it is equal to zero point 0.5. Okay, so when you ask for the a is equal to 5, because the 5 is also element inside of that for f, and it is a one of the subset of that overall set. So a is equal to 5 because there is no element, so mod of a is equal to 0, and the probability of a is equal to 0. So here we have defined that what is a subset, what are the sample spaces, what is the probability function it is given, and how to formulate that, keep putting the elements and seeing that how the probabilities variations are there. Okay, so these are the proper points which is needed to be understand to be solved the problem. So important point here is the first is the probability space, second is the sigma algebra. If you see here, the sigma algebra is one concept here it is given. So let's understand this concept. Okay, so first is the probability space. If you see that omega is a sample space which is clearly defined a finite set, because it is having a four elements which is being said that it is a finite set. If the number of elements is not finite and it is more than what is actually it should be there, so it is a kind of infinite, means 1 2 3 4 dot 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 till infinity. So it is a kind of infinite set. The finite sets are that which is having fixed number of elements. Second test is that sigma algebra, whether it is this function which is being defined is equal to 2 to the power omega, is actually a sigma algebra or not. Okay, so there are three criterias to see that whether it is a function is a sigma algebra or not. First, if it is a function, means if it that omega which is a set is, it should also be a subset of that f. F is a major set, and this subset, that is omega, is actually belong to that subset. Let me see that how it is being. If you see the right side image, if you see this function f, this is a function f, If you see that, this is a function f which is defined inside of that, means all the subset. When you see that key a subset counting that key elements and all, so it's a kind of f is equal to 2 to the power n, means containing the all the subset. And if you see this omega, whole word is included here, that is function f. And a is a function which is being said that key the elements and subsets inside of that. Suppose if here if you see that key a is 1 2 1 2 means it's a subset. Okay, so here if you take the one subset as a, okay, and then the if you see the a complement, if you see this whole of the function f, okay, and AC is the complement of a, okay, so a complement is this much will be there, okay. So the major thing is that this sigma must be belonging to the f, okay. This sigma, this omega, sorry, omega should be belonging to a function of f. So here it is belonging that it is having one element as a, and this is a complement, and both addition will be given to that omega, this whole word, and it is belonging to the function f, okay. And f, what is f? F means containing the all the subset, not the a only, that a 1 2, either it will be a single element or the 5 or also will be there, so it's a containing of the all the subset. And second point is that be closed under the complements, all complements are included in the power set. What does mean? It means that, let me take here, suppose this is a overall set f, okay, okay, this is a probability function. If you're defining a here, this is the a, suppose I am taking this is the a, okay. So what do you mean by the a complement? A complement here will be simply will be equal to here this, okay, because the a plus a complement will be equal to the function if the only a subset is there inside of this function, okay, f, okay. So the a plus a complement will be equal to the f if there is a no other element which is possibility here, okay, no subset, okay. So it means that ki a and a complement will be included in that overall power set, okay. So this is a kind of a closed under the complements, okay. And the third point is that be closed under the countable union. The power set is closed under the union. F is the sigma algebra. It means that suppose I am considering A and the A complement here. The union, if you see the A probability of finding of the A plus probability of finding of the A complement will be equal to the 1. Okay. Second way also you can understand that ki A1, suppose here if there is a superset and there is a A1, A2, A3, there are different kind of subsets are there. A4 is there, A5 is there. So when you take the union of that, the A1 union A2 union A3, this forms the overall set, okay, overall set F, okay. So these are the concept that when you are having the three possible conditions which can be fulfilled, you can say that F is a sigma algebra. And the third point which is important to understand that the if how you see that whether this p is a actually a possibility is there, it the probability can be measured or can be said that it should be a probability space, that is p. So there are three conditions which must be hold to find that whether this p is a probability space or not. First, probability can never be negative. Okay, it should be equal to 0. Possibility is there, and it should be greater than 0. Here also that is a non-negativity. Non-negativity means probability cannot be negative. It can be 0. It can be greater than 0, but it should never be negative. Here also if you see that this probability becomes a hold because the mod of a greater than or equal to 0. Mod of means number of element should be greater than or equal to 0, okay. And if the elements are negative, that is never be possible, that a number should be countable, okay. So a, suppose having the element 1 and 2, you cannot say that it will be negative. It can be 5, 5, a can be 5, but cannot be negative, means number, counting number cannot be negative. It can be 0 1 2 3 4. So it means that hold this probability is holding because the number of elements here in particular subset or set is greater than equal to 0. Okay. Second concept is normalization. Normalization means when you're counting, suppose this is the function f and having the subset a1, a2, a3. So probability of finding union of finding the single subset. Suppose I am considering a1, a2, a3, a4 or a5. The probability of finding a1 plus union plus probability of finding a2 plus probability of finding a3 dot 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 probability of finding the nth term or the last subset is equal to 1. Okay, so miss normalization, all the possible subset having the probability summation will be equal to 1. That is called a normalization property. Third important is the countable additivity. That is very very important, that ki probability of A union B is equal to probability of A plus probability of B. Why I am saying that? Let's take one example. Let me take a slide, new slide here. Let me explain that what is being said in this. Suppose it is saying that the countable additivity. Okay, and the condition is such that if you see that A and B are disjoint, then the probability of A union B means when the two sets, suppose this is a set and this is the B set and this is the overall space F. Okay, and this A and B don't have any element in common, so A and B are said to be a disjoint set. Okay, disjoint set. And you already know that the probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Okay. And here if you see that what is the actually the A intersection B is here is 0 because they are the disjoint set and no elements are common in between the both. So simply it became probability of A union B is equal to probability A plus probability B. Okay, so that is actually being seen from here also. If the probability A having the element 1 and 2, B is having the element 3, what is the probability of A? Because the probability of A is defined as the mod of A by 4. Okay, mod of A means number of elements in A. So if you see here, the number of element here is the 2, means 2 divided by 4, that is 0.5. And B having the 1 element, it means that the probability will be 1 by 4, that is 0.25. When you take the union, means probability of A union B, A union B will be equal to 3 elements, 1, 2, 3. Okay, when you divide this 3 by 4, that is 0.75. And when you add this probability of A and probability of B with 0.5 plus 0.25, that will be equal to 0.75. Okay, this is the important concept. Three possible important points which needed to be understand. What is a sample space? Second, how can you call a function to be a sigma algebra? Third point is that how you can say that this probability P is a probability measure. Okay, it's must satisfy the three criteria to be called as a probability measure. Okay, let's take further deep and down and see this probability sigma algebra function is very very detailed way. Okay, let's see how can you call a function as a sigma algebra. Okay, if a sigma algebra over a sample space sigma, this omega is a collection of subsets of omega which satisfy three property. First, this function, you can say the omega by definition should be belonging to the function of f. What does mean? It means that suppose this is a overall function space f. Okay, and this is sigma omega, sorry. So the omega must be belonging to f. That is very very important. What it mean? And also this f is the 2 power omega. Why it is saying that ki, because when you see that how many possible subsets are there in f, it should be equal to f should be equal to 2 to the power n, and here is 4, so it will be 2 to the power 16. So all the possible subsets of f will be equal to this omega is actually equal to 16. Okay, and all this subset will belong to f. Why? because this omega is still belonging to the f, so all the subset inside of this omega will be a will be belonging equal or equal to the sigma, or it should be belonging to the f. Okay, so if you see that this omega is having the element 1 2 3 4, so it will belong to f. That is very very important point to understand. Okay. Okay, so let's see that second property. Any doubt? Are you speaking? If you find any difficulty, just write in the chat box, or you can open your mic and ask me. Okay, we will understand the concept which and build up to solve these problems. Okay, let's move forward. If you see the second criteria, this you understand that if there is a set that is omega and it is inside of the sample space that is f, so the sigma omega must belonging to the f, and also the subset inside of this omega will also belong to the omega, and also this belonging to the f. Okay, or you can say that suppose this is not so. If you see the function f, it should be like that. Suppose let me take any other value. Let me erase this. Suppose I am taking this x. X is all the subset of omega. How many subsets are possible? That is 5, that is 1, that is 2, that is 3. So this all will be, this 5 will also be a subset of this, and this is also a subset of f. Means this 5 or this 1 is belonging to 1, that is belonging to omega, that is also belonging to the f. Okay, that is more important. That is first criteria. Second criteria, let's understand. If I am saying that a is belonging to the f, suppose I have taken a sample space f. Okay, and this is a set a. If a is belonging to the f, then it must be that its complement should also belong to the omega, or you can say that a must also be in the function of the f. Okay, let me say how it is like that. Suppose there is a one space that is only a is there. Okay, so this is the a. What will be the a complement here? A complement will be this much space. Okay, so it means that a is belonging to the f, and also a complement is belonging to f. Okay, or you can say that suppose there is a subset inside of that. There is a subset inside that, and it is called as x here. So it means that x is belonging to a, and a is belonging to f. Okay, but when you see the a complement, okay, a complement, this x element inside of that is very different from the a complement, because it is not coming inside of the a set. Okay, so the a complement is belonging to the f. Okay, but it is not belonging to the a. Okay, so what I have written, if you see, read it out also. Since f is a power set, this is f is a power set, and every subset complement to also a subset of omega. Okay, it means that suppose this x is there. Suppose I am wanted to take the x complement. X complement will also be a subset of a x complement will also belong to, because this is x, no. So x complement is belonging to a, or you can say that xa is a subset of a x complement, and x is also a subset of a. Okay, so here you can say that x is also a subset of a, x complement is also a subset of a. So it means that this x is also belonging to the f, and x complement is also belonging to the f. Okay, that is main point to be understood. Let's take one example. What is written here that a is having a subset 1 2, elements as 1 2. A having a set, a is a set which is having the element 1 2 1 2, and you already know that sigma is what is 1 2 3 4. So what is the a complement? A complement is 3 4. If a is belonging to f and you already know this is belonging to the F. So A complement will also belong to F. That is same criteria. X is belonging to A. X complement is belonging to the A. So X is also belonging to the F, and X complement is also belonging to the F from the same criteria. Okay. This is the second point to be understood. Let's take the last point to be, which is very important to see that whether it is sigma algebra or not. Third property is that if you are having a set subsets a1, a2, a3 which is belonging to the F, so their union will be, must be, also will be there in the F. Okay. So let's see that. Suppose A is 1, B is 2, 3, A union B is 1, 2, 3 belonging to the F. So all the elements which is being inside of that sets, that will be equal to the that will actually form a sample space of F. Let's take one example to be understood by that. Let me take duplicate here and let's erase this. Let's erase this. Let me say what. Let me write it. What I'm telling here, that suppose there is a sample space F, and there are certain elements are there, subsets are there, A, B, C, D. Here, one important point to be seen that if you see that A, B, C, D, they are disjoint sets, disjoint subsets. You can say that is actually or you can say that sets. If you are considering F the overall sample space. Okay. So you already know that A union B is equal to probability of A plus probability of B minus probability of A intersection B. Okay. Here there is no common point in the A and B, so it will be equal to 0. It means the probability of A union B is equal to probability of A plus probability of B. So similarly, if you see that probability, what is the probability of A union B union C? So it will be simply equal to probability of A, probability of B plus probability of C. Okay. If you wanted to take the overall sample space, that A union B union C dot 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 till the last, suppose I am considering X, it will be equal to probability of A, probability of B, probability of C dot 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 probability of X. That is the important point to be understood. When the A and B sets are disjoint, if you consider all the subset which is possible into the F, that is actually summation will be equal to, their union will be equal to simply the summation of that. Okay. That is same thing it is written here. If you see here, because all the subset which is possible, that is 2 to the power n. Okay. F is equal to 2 to the power n, which is contain the all the subset of omega. It automatically satisfies that all three sigma algebra properties, that is F is a sigma algebra. Okay. That is important point to be understood to solve the problem. Let's go to the problem first. Let's go to this problem. What is asking that omega is 1 2 3 4, F is 2 to the power omega, whether it is sigma, it is forming the probability space or not. When you see the probability of A, it is should be equal to, greater than or equal to 0. That is actually there because the elements are possible into the subset, that is F equal to 5 1 2 dot dot dot. So the probability of 5 will be equal to 0, and probability of 1, when you wanted to find it out, that this, that is equal to 1 by 4, because the element is 1, that is 0.25. When you add it up, it is actually form a union, that will be equal to the 1. Suppose let me take example, A is equal to 1 2 and B let's take as 3. Okay. What is the probability of A? Probability of A will be 2 by 4 because two elements are there, that is equal to 0.5. When you say the probability of B is equal to 1 by 4 because one element is there, that is 0.25. What is probability of A union B? A union B is simply 1 2 3. Their probability is equal to probability of A union B is equal to 3 by 4. When you say that 0.75. So When you sum up this point 0.5 and 0.25, that is equal to 0.75. So it means that it is forming a probability space, that f, p and sigma. So the correct option will be equal to the yes. It is actually forming the sample space, a probability space. Let's move to the second problem. If you understood that case sigma algebra, what is a sigma algebra? Okay. Any doubt you can ask in the chat box, or you can open your mic and let me know. Okay, try to solve this. Here it is saying that ki f is a sigma algebra over omega, and which option should be true if it is a possibility is there. Take your time to solve this. Understand that ki how actually sigma algebra could be defined in the sample space. Three criteria you already know. First, that is already being said that ki when the particular element, suppose this is there, a this, suppose this is a, this is f, a is belonging to omega, that is belonging to f. Second, if you are having a and this other sample space is a complement, so a is, and this is all sample space omega, a is belonging to f, so a complement will also belonging to omega, it is also belonging to omega, and that is belonging to f, and this is also belong to f. Third is that ki when you see that how, suppose, let me see that uh, suppose that you're having the all the subset a1, a2, a3, that is disjoint subsets. So union of I is equal to 1 to n, that is equal to a I, that is equal to probability of a1 plus a2 plus a3, that is simply okay. That is important point, that ki summation of all probability the elements are disjoint, so that is actually correct. Okay, try to solve based upon this concept this problem. You can write in the chat box whatever the answer you are getting, or you can open your mic and also tell the answer. If you are not able to understand, you can also write in the chat box that I'm not able to understand the problem. So I will explain directly and provide you the way to understand and solve this problem. Okay, let me explain the problem first. So it will be easy to understand and solve. Let me make you understand and comfortable with this problem. Let's see what is actually trying. It says it's saying that f is a sigma algebra over omega, which must be true. Whether phi you already know it's a if it is a set having no element, that is called as phi. You already know what is f actually a bigger set, means ki overall sample space, and this omega is a subset of that. Okay, and it is belonging to f kind of. Okay, let's understand that. Okay, let me make you feel comfortable. So let's see that what is actually a definition of sigma algebra that we have already seen, but we will actually see it again. Okay, it contains the whole space. Whole space means this omega is actually belonging to f. Then it is called as the sigma algebra. F over a set omega is a collection of subsets of omega. Okay, it means that this is the overall sample space f, and there it is omega. It means that omega is belonging to the f. First criteria. Second, a is belonging to the f, then a complement is omega, that is called as it is also such that a is belonging to the f. Okay, so let's see that what is actually telling that suppose this is a, this is a here, a, and the other will be a complement. This is a complement others. Okay, if this a is belonging to f, belonging to the f, and this a complement is belonging to omega. Okay, then you can say that this a complement is belonging to omega, that is belonging to the f also. Okay, and the third criteria is that closed under the countable union. Okay, so this is the overall criteria that I have told that key, if not only a is there, there is other elements also there, a2 is there, a3 is there, a4 is there, so that all the union will be belonging to the f there if there are disjoint sets. Okay, why 5 must be in the f? So if you see the problem, let's see the first a option. A option is telling that ki phi does not belong to f. That is actually false. Why? Because the phi can also be a subset of f. Okay. If you see the all the condition f is equal to the power omega, what the function will contain? It will contain as phi. It will also contain 1. It will also contain 2. It is also contain means 1, 2, 3, 4 kind of dot dot dot. So there are, if you see that key phi is also belonging to the f because it's a kind of a set. Okay, a subset. Okay, so the first is false. Whatever second, the option b, if you see this omega is belonging to the f and phi is belonging to the f, that is always true. No, if you see the sample space f, you are having is phi, and this phi is belonging to the f, and also this phi omega is belonging to the f and phi is belonging to the f. That is true. Now phi is belonging to the f, and this whole set that is of omega is actually belonging to the f. That is true. B is true. Let's see that why c option is not correct. See, if you see the f contains only finite set, that is doesn't make any sense when you're having the a multiple number of elements in there. Suppose f is here, no, so there can be a possibility of number of subsets. Okay, that can be a forming the whole sample space of f, that is can be a infinite sets inside of that. Okay, it can be a finite, cannot be a finite also. Okay, so the c option is incorrect. F contains only countable set. If it is a finite set, you can count it, and if it is infinite set, then also you can count it, but it can be countable, it cannot be countable. Okay, counting starts means ki 1 2 3 4 dot 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 till the n natural numbers, because the counting will never start from the zero, that is whole number. Okay, 1 2 3 4 you can write in the sequence 1 2 3 4 dot dot dot, whatever the elements are there, that makes it a countable or uncountable sets. Okay, so d is false, so the correct option is b. Okay, any doubt in this? Any doubt? Okay, let's move forward and try to solve the next problem. Try to solve this. Here it is saying that k sigma algebra on this it means that k, suppose this is f and this is g, so sigma is also here and sigma is also here, kind of. Or you can say this also, like this: f, this is f, this is g, and this is forming whole of the set s, and sigma is lying here also, sigma is lying here, kind of possibility. Try to solve this. Which option is correct? Any answers? Let, I'm waiting for one more minute, and, and read it out and try to solve that. Let me give you 2 minutes more. Okay. Okay, let me explain this. Okay, let me explain this problem. What is telling that we are having a f and g sigma algebras on omega, and what which of the following is always a sigma algebra? Okay, either it is f union g, f intersection g, or the elements in f which is not there in g. Okay, or none of them. Let me go step by step. First important point is always that what is actually sigma algebra, which is already we have seen. Let's see it again, that omega is belonging to the f, that we have seen. Second, if a is belonging to the f, then a complement will also belong to the f, closed under the complementation. Third point is that if you are having a subsets a1, a2, a3, a4 and all are disjoints, and then the union of I to the infinity, that is belonging to the f, or if it is not a disjoint set, then their union will be equal to the f. Okay, belonging to the f. Okay, why this interaction matters? Okay, why? Because this is we have defined for the one, that is f. What about when you are having a g also, which is a kind of sigma algebra over a set omega, because the two functions are there, sample spaces are that f and g as well. So if you see that key f and g, if both are sigma algebras on the same omega, then containment of sigma, that is sigma is belonging to the f, and sorry, omega is belonging to the f, and omega is also belonging to the g. It means that if it is belonging to the both, it means that there is a common point in between the f and g. There the sigma is actually occurring. Why? Because they that is also belonging to the f area, and also that is belonging to the g space as well. So it means that there should be a common point in between the both, that is f and g sample spaces, where this omega actually exists. Okay, some portion can be in f, some portion can be g, but there is some common sample space in between the f and g where the this omega actually belongs. Okay, second point is that that closed under the complement. It means that the second criteria, that is, if a is belonging to the f intersection g, it means that a is belonging to the f, a is belonging to the g. That is same concept, that key if sigma is belonging to the f, it means that if sigma is containing the element a, like this, suppose this is f, this is sigma, and this is a. Okay, if a is belonging to the f and belonging to the omega, a is belonging to omega, it means that omega is also belonging to the f. Okay, or you can say that a is belonging to the f. Okay, same criteria, a is belonging to the f and a is belonging to the g. Okay, so it means that a complement will also belong to the f. Why? Because a is this, so the a complement will be this, so that is also belonging to the f. Okay, and similarly the a complement will also belong to the g. It means that if a complement is belonging to the f and a complement is also belonging to the g, so there should be a common point in where the a complement is also existing in between the both the sample spaces. It means that a complement is belonging to the f intersection of g. Okay, getting my point? That key if omega is belonging to the f and that omega same is belonging to the g, it means that there is a common point in between the f and g where the intersection exists and that omega actually belong. And if you see that key inside of omega, you are having a element subset a that is belonging to the f, and that is also belonging to the g, so their complement will also belong to f, and that complement belongs to the g. So you can say that a complement belong to the f intersection of g. Third criteria is that if a1, a2, a3 belonging to the f intersection g and ai belong to the both f and g, since both are sigma algebras, that i's union of a all the ais, that is equal to the belonging to the f, and same is belonging to the g, because there is a common point in between both the intersections. Suppose I'm taking this Suppose this is F, this is G. Here, suppose the sigma is actually belonging. This is sigma. This portion. This is sigma. So it means that there are some subset inside of this omega, that is A1, A2, A3, A4, A5. That is their union. Their union, that is equal to I is equal to 1 to suppose infinity. That is A1, A2, A3. That is AI. That is belonging to the F only. Okay. That is also belonging to the G as well. Okay, because this is a common portion in between the both this. Okay, you can say that this AI is actually intersection because it is existing in between the both, so that you can say that. So it means that F intersection G is actually a sigma algebra, not the F union G or the elements of F which is not belonging to the G. Okay, so the option B is actually correct. F intersection sheet. That is very very important to understand that how if the two sample spaces are there and there is some common elements in between the both subsets are there, so their interaction, if both sample spaces sigma algebra of set say omega, so that intersection is also a subset of omega. Okay, that is sigma algebra of omega. Okay, any doubt in this? I hope this point is clear for this. Let's move further. Let's move further for the remaining next problems. Just understand that how you can say that this is actually a sigma algebra F G on a subset set omega. Okay. I think it's the same problem. Sigma, which of the following is always, that is F intersection of G. Okay. Let's move forward. Which of following is true for any set collection C? That is sigma of C is the largest. I think it's not that much important. Sigma C and D. This. Try to solve this. This is important. If you having a omega that is finite set with the n element, what is the maximum number of sets in the sigma algebra over omega? You can take one example that suppose sigma is a finite set element. Suppose you are taking 1 2, take it at and try to fit in which is option is actually matching. You can type in the chat box if you get the answer. Okay, let me explain this problem. So it will be easy to understand and grasp. So if it is saying that key sigma is a finite with an element, and what is maximum number of sets in the sigma algebra over. So let's see that. Important concept that important is the from the first point itself. What is sigma algebra that we have already seen in multiple times. Okay, and the key facts are there. A sigma algebra over omega is a collection of subsets of omega satisfying that sigma algebra property. Sigma algebra properties are three properties we have already seen. Okay, so sigma algebra is a collection of subsets of omega satisfying this sigma algebra properties, and largest possible sigma algebra set over is the 2 to the power omega, which contains the all the subsets. Suppose I am considering sigma as a 1 2. So how many subsets are possible inside of that? Subset will be suppose I am considering as a f, subset will be equal to 5 comma 1 comma 2 comma 1 2. Okay, how many elements are there? That is equal to 4, that is equal to 2 square. Okay, and what is 2? 2 is actually mod of sigma, that is number of element inside of the sigma, that is equal to 2, that 2 to the power 2 is equal to 4. Okay, so that is important point, that when you are having a sample space f, and inside of that you having a set that is omega, and omega is containing the elements that is 1 and 2. So the number of subset which is possible at 2 to the power n. Okay, and that number, that is 2 to the power sigma, is actually equal to 2 to the power n only. And this comes from the fact that each of the n element there are two choices, include or exclude it from the subset. Okay, 5 1 2 1 2, either you can include or you can exclude. That is called as f, is actually called as the power set. This is called as the power set. Okay, checking the options, that option n, because if you see the n means ki it will come out to be 2, because here there are two elements are there, so it is very small, that cannot be possible. Okay, because if you see the two element 5 1, that is actually two elements is already there. Okay, so this is false. N square not correct, because the number of set is exponential, not quadratic. Okay, 2 to the power is actually correct, which we have already seen, and factorial no, it is not permitted. Okay, so the correct option is 2 to the power n. Okay, so it means that for the finite omega with having the n element, the maximum size of the sigma algebra which is possible, that is equal to the 2 to the power number of elements in the subset, that is equal to 2 to the power n sets. Okay, let's move forward, try to solve this. This is an important concept of Borel set, which we will see coming after this. Okay, if you know already the concept, try to solve this. Otherwise, we will go further and see the what is the Borel set. I'm giving you 2 minutes. If you already know, try to solve. If you do not know, after 2 minutes, I will explain it. Okay, let me give the solution for this. Let's first understand that what is actually a Borel set is. Okay, the definition of the Borel sigma algebra is like this. Suppose the Borel sigma algebra on R, that is real number denoted by BR, that is Borel sigma algebra of R, is generated by all open sets in the R. Okay, by the sigma algebra property, you already know that you have a countable unions, countable interactions, and complements. Okay, why the complement is also a Borel set? Borel set means ki, if you see the open interval in the image, that is open interval 0 to 1. The Borel sigma algebra is 2 to 2 5 element 0 1. This also that ki you having the closed and here is the open, and the complements countable union and their interaction is called as the Borel sets. Okay, let me further explain you. Okay, if A belong to the Borel set of R, then by the closer enter the complement, that is also that AC is the all the real amount which is not included in the A belonging to the B and R, that is not in the A, is actually a complement. Okay, all the open sets. Open sets means ki that is 0 1 you are considering. Okay, 0 1 you are considering here, the one you are considering, 1 here, 0 you are considering. This is a kind of closed set, that is 0 1. Okay, so the Borel set means ki all the sigma algebras which is generated by the open sets in R is called as the Borel sigma algebra. Okay, and checking the option that ki first what is saying that ki yes or no correct, because the complement of Borel set in R is always a Borel set. That is true. Why? Because if A is belonging to the BR, means ki all the open subsets inside of that, the A complement will also belong to the R. Why? Because that is also a sample space now that we have already seen. Suppose this is F and this is A, and so the other part is the A complement. That is simple form. That key it's a open means this boundary is not a closed. Okay, the 0 1 element means suppose this is let me take other. Suppose this is the A1. Okay, and this boundary of its is also inside of the A complement. Okay, so that doesn't matter no? If you are having not means closed sets, that is also a open sets, so that part will be inside of the your domain which is not included in the A complement. Okay, so that but A complement that will belong to the overall R. Okay, so let's move further. Here the question is that which of the following sets are always Borel sets? That is actually the all the open intervals. Okay, and but here the option problem is that open interval also, closed interval also, all finite union also. Because if you see here what I have uh, depicted here, if you see this 2 and 5, it is also a closed set. 0 1 is a open, 0 1 is open, and you can see that this all the there are the open intervals also, closed intervals also, finite union of the intervals also. These are all the options are actually correct. Okay, let's move further. All the open intervals in those sets, which is actually correct, that yes, all the open intervals also different depending upon that whether it is actually open sets of all the R's or not. Okay, uh, here I've already given the answer. Let's move to the few important concept. This is Borel sets, Um, let's say probability spaces. So let's try to solve this. Okay, try to solve this problem. This is from the probability space. Okay, Okay, let me solve this. What the question is actually saying that ki probability of A is actually greater than or equal to 0, and probability of this omega is actually equal to 1, and this P is necessarily a probability measure, and whether this option is actually correct or not. Okay, there are three properties which we have already seen that the probability of A will be equal to greater than or equal to 0. That is first property. Second property is that all the elements which is belonging to the sigma omega will be equal to 1. What I am saying that ki suppose let's take the few of the disjoint sets. Disjoint sets we are taking like this: A1, A2, A3, A4, A5, A6. So these all the sets which you can see of the sample space F is actually a disjoint set, but the all the probability when you add it up, the probability of a1, probability of a2 plus dot dot dot, that is simply equal to the probability of a1 union a2 union a3 dot dot dot. So when you all the subsets are there, and when you normalize it, the summation will be equal to the probability of sigma will be equal to the 1. But these two probability holds, but there is a one more property is there, that is this, which we have talked about, that is additive property. So the B option is actually correct. When you are having these two criteria, you must check for the third additive property. Here we have already, I have wrote it down, you can read it there. First, probability measure definition, that is actually a probability measure P on a sigma algebra F must satisfy that the non-negativity property, probability of all the A should be greater or equal to 0 for all A belonging to the F. Second is the normalization, that is the probability of sigma omega is equal to the 1. Countable additivity for disjoint sets A1, A2, A3 belonging to the F. So the probabilities of union of A1, A2, A3 dot 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 will be equal to summation of the probability, which I have already explained here. And if you see that key, what is this meaning of this? It is meaning that when the two or more events can't happen at the same time. Here if you see a1 a2, they are not happening at the same time because they are disjoint sets. Okay, the probability of the occurrence of a this occurrence of a is actually not related to the probability of the occurrence of a2. Okay, so that's why when they are the two events which are not happening at the same time, the probability of one of them happening is the sum of their individual probabilities. Okay, what it means that ki probability of A union B is simply equal to probability of A probability of B. Means this probability cannot happen at the same time, so they just sum it up their individual probabilities, and you will get that key countable additivity. That is very very important to check. Okay, first option, if you see the yes, no, that is false because you have to check the additivity, and this is for it can be infinite, it can be uncountable as well. Okay, so the correct option is B. You should check the additivity. Try to solve this. This is a very simple problem, but I hope you can understand and solve that. can write in the chat box also if you get the solution for this. It's a simple problem, but the basic concept involved, which I have already explained in the few points. Try to solve. Basic. Okay, let me explain that. It's a very easy. If there is sample space F, if A and B are disjoint, A and B means no elements are common in between the both. So it means that when you see the probability of finding of A, probability of finding of the B, that is A union B, will be equal to probability of A, probability of B, because probability of A intersection B is actually equal to 0. Okay, so the option A is correct. Okay, so this is not correct, this is not correct, this is not correct. So probability of A, probability of B. Let's try to solve this. Okay, let me give the solution for this. So in the problem, it is saying that there are two independent subsets, that is A and B. What is the probability of finding the A intersection B or A union B? What the criteria can be holded? Okay. If you see that key probability of A and B is equal to probability of A union B only when the possibility is that key both are sets, independent sets. Okay, but not the A intersection B. Okay, let me see that. Okay, suppose there is a event 1 and event 2. Event 1 is getting a 6 after rolling a die. Event 2 is getting head after tossing this coin. Okay, so what is the probability of getting 6? Probability of event 1, so that is event 1 is equal to 1 by 6. What is the probability of event 2? That is equal to 1 by 2. Okay, so when you see the event 1 and event 2, occurrence of event 1 is independent of occurrence of the event 2, and both are very separately. Here we are not saying that key when you get 6, then toss the coin. It means that the both events are dependent to each other, but here when you are seeing that it is not dependent, it is independent. We are not saying that ki when you are tossing a coin then roll the die, or when you are rolling a die toss the coin. Okay, both the events are actually independent. Okay, so the probability of E1 intersection of E2 is very separate. That will be equal to probability of E1 multiplied by probability of E2. That will be equal to 1 by 6 multiplied by 1 by 2. That is equal to 1 by 12. That is correct answer is probability B option. Okay. Let's move to the last problem. Try to solve this. Take few minutes and read it out and try to solve that. So let me explain this. Suppose there is a set A which is having element 5. It means that there is no element existing. So the probability of non-existence of any element inside of a set is actually 0. Okay, because there is no element. So correct option is option A. So if you see that what we have seen today, that what is actually a probability space, where we have seen that probability space having the three criteria, that is non-negativity of the PA, that is PA should be greater or equal to 0 for all A. This hold because mod of A is greater or equal to 0. Second is the normalization, that is P of omega is equal to 1. Here in this problem that omega was 4, so the probability was mod of A by 4, that is 4 by 4 is equal to 1. Countable additivity, it means that if the A and B are disjoint sets, PA union B is equal to PA plus PB. Here from the example we have already seen that A is equal to 1, 2 and B is equal to 3. So the probability of occurrence of A is mod of A by 4, that is 2 by 4, that is equal to 0.5. Probability of occurrence of B is equal to 1 by 2, that is 0.5, 1 by 4, that is 0.25. When you see that the probability of occurrence of A union B, that is equal to 3 by 4, 3 by 4, because the 1, 2, 3, three elements will be there, that is equal to 0.75, that is equal to zero point 0.5 plus 0.25. Okay. And the concept of sigma algebra also we have seen, that is a containing of the omega first, which is belonging to the overall space F, because the F is actually the contain the all subset which is belonging to the omega, that is 2 to the power n. How many number of subset which is possible, that is equal to 2 to the power a mod of omega, that is number of element inside of that, that is 2 to the power n. And being at the closed under the complement, that is odd complement are included in the power sets, and the closed under the countable unions, the power sets is closed under the union, that is all the criteria when it is possible, then it is called as the sigma algebra. Okay. Then we have already seen that from the example itself, then we have solved few of the problem. Here also the important point is that when the F is a sigma algebra over omega, then which must be true that omega is belonging to the F and the phi is also belonging to the F. Here the point was that there are two F and G, which is both the sigma algebras in the same omega. So the here we have seen that a containment of sigma, that is sigma belonging to the F and sigma belonging to the G. So we have that sigma belonging to the F intersection G. Second is the closed under the complement, that is A belonging to the F intersection G. So A is belonging to the F and A is belonging to the G, since both are the closed under the complementation. So the A complement is belonging to the F, so and A complement is belonging to the G. So A complement is belonging to the F intersection of G. Closed under the countable union, that is the if A1, A2, A3 is belonging to the F intersection G, then the AI belonging to the both F and G. So since the both are sigma algebra, so union of AI will be from the I to 1 is equal to infinity belonging to the F, and similarly they belonging to the G. So if you can see that belongingness of the AI is starting from the its a union of from 1 to infinity, that is actually equal to the F intersection of G. So both the F and G having the if F and G is a sigma algebra, so F intersection G also is sigma algebra. Okay. Then we have seen the Borel sets, which is with a few properties and all. That is a Borel sigma algebra on R, denoted by BR, is a sigma algebra generated by all the open sets in R. So okay. And then we have seen the few of the problems related to the probability space also, uh, probability space also, and this is the probability of a this probability space, then definition of probability measure, then A intersection B is equal to PA plus PB. A intersection B is equal to the PA multiplied by PB when the both the events are actually disjoints or sorry independent. And here we have seen property that probability spaces, that the additive property is important, non-negativity, normalization, and the countable additivity. Second is that p phi is already equal to 0 because there is no element, so you cannot find a probability that is equal to 0. Okay. So that's all for today's session, and we will meet in the next session, which will help to solve the other assignments. That's all for today. Thank you so much.